How does latent heat of vaporization explain boiling? Have you ever wondered why boiling water stays at the same temperature even when you keep heating it? This question leads us to the fascinating concept of latent heat of vaporization. Let's break it down in simple terms. Boiling happens when a liquid transforms into a gas throughout the entire liquid, not just at the surface. The latent heat of vaporization is the energy needed to turn a liquid into a gas at a constant temperature, specifically at its boiling point. This energy helps overcome the forces that keep the liquid molecules together without increasing the temperature. Take water as an example. When water reaches 100 degrees Celsius, it is at its boiling point. However, it does not instantly turn into steam. It requires extra energy, known as the latent heat of vaporization, to break the bonds between the water molecules. These bonds, such as hydrogen bonds, hold the molecules in the liquid state. Once enough energy is provided, the molecules can escape into the gas phase as vapor. Interestingly, while water is boiling, its temperature remains steady at 100 degrees Celsius until all the liquid has turned into vapor. This is because the energy being added is used for the phase change rather than increasing the temperature. In thermodynamic terms, the latent heat of vaporization represents the energy absorbed by the system during this phase change at constant temperature and pressure. This energy is considered hidden during the phase change process, which is why it is called latent heat. Water has a high latent heat of vaporization, about 540 calories per gram or 40.65 kilojoules per mole. This high value explains why boiling water requires a significant amount of energy. The energy absorbed by water molecules helps them overcome the strong hydrogen bonds, allowing them to transition from liquid to vapor. From a practical standpoint, understanding latent heat of vaporization is essential in various thermodynamic systems and cycles. It is crucial for designing equipment like boilers, condensers, and heat exchangers. Boiling is an effective method to transfer large amounts of energy without raising temperature, which is vital in applications such as power plants, refrigeration, and cooking. Latent heat of vaporization clarifies boiling by quantifying the energy needed to convert a liquid into a gas at its boiling point without changing temperature. This reflects the energy required to break intermolecular bonds and allows the phase change to occur.